particles are moving along the line x plus 2y equals 3. So let's draw that. Okay, approximately. Now when x equals 0, its y-intercept is going to be 3 over 2. So let's say that's 1, 2. 3 over 2 is 1.5. So that's the y-intercept. If you set that equal to 0, it has an x-intercept of 3. 1, 2, 3. Okay, so we're talking about a line that roughly looks like that. Okay, and then it says when x is equal to 1, so there's a particle that's moving along this line here. And this particle, if you've done vectors, it has two motion. There's an x motion and there's a y motion. Okay, so these two combined, right, at 1, right, it's 2 units per second. Okay, so that at that particular moment, this speed, the rate of change of this distance, is 2 units per second. Given that, what is the distance? How fast is the distance from particle to the point 1? There should be 1 comma negative 1 changing. So 1, negative 1. Okay, so you can imagine. Let me change the color here. Right. Given us how fast the point is moving, but we are actually ultimately interested in knowing how fast is this distance. So if the particle is here, that'll be the distance. Right, that'll be the distance. That'll be the distance. So at this moment, right, do you see how the distance is shrinking? What is the rate of change of this distance with respect to time? That's the question. Okay, so let's call this distance s. So it's really asking us to find ds over dt. That means we actually need to find s, right? S in terms of x and y. So s is a function of x and y. And we can do that simply using the distance formula. So s is equal to, right, the distance formula comes from the Pythagorean theorem. So if you remember distance formula, it's s is equal to the delta x squared plus the delta y squared. The delta x, right, so this point here is 1, negative 1, right? A point on this line, okay, so I mean this particular point may be 1 and something, but just a random point on this line, right? It's called xy. Okay, and this x and y, I'm referring to the same x and y in the original equation. So the delta x will be then x minus 1, and the delta y will be y plus 1. Now I'm going to square both sides so that I get s squared. Okay, s squared, because we can implicitly differentiate both sides at this point and still get ds over dt. Now if I differentiate here, okay, with the square root, the right side will get unnecessarily too complicated. So let's differentiate this instead, and we get 2s times ds over dt. And you get 2x minus 1 dx over dt, and 2y plus 1 and dy over dt. You can simplify this by dividing everything by 2. Okay, now x is given, x is 1, and dx over dt is also given to be 2. Okay, so if x is 1, this is actually going to turn out to be 0. So we need we need the value of y and dy over dt to find the ds over dt. Okay, and we also need the s value as well. So we need the s, the y, and dy over dt. So where do we get that? Well, we get that from the original equation. Since x and y have a constant relationship bounded by this line here, we can differentiate both sides with respect to time on the line. So we get dx over dt plus 2 times by dy over dt. Differentiate the 3, you get 0. So this right here is given 1. And look, we can find what dy over dt is. It's going to be negative half. Okay, so we found this. So how do we get the y value? And y, well, y is the point when x is equal to 1. So when x is equal to 1, 2y is equal to 2, so y is equal to 1. So we found that as well. And where do we get the, right? Where do we get the s? Well, now that we have the x value and the y value, right? Now we can get the s value using s squared. X was 1, so it's going to be 0 squared. Y was 1, so it's going to be plus 2 squared. So s is actually equal to just 2. Okay, this makes sense. There's a vertical distance. So we have s now. So we have 2 times ds over dt. Y was equal to 1, so it's 2. dy over dt is negative half. So ds over dt, ds over dt is equal to negative half. Okay, negative half, this is a unit, right, per second. And it's negative to represent that distance is actually shrinking.